So, hello everybody. My name is Emanuel Zattin, and yeah, I work at Realm. But enough about me. Let me ask you something of me. I guess all of you are Android developers. Any of you is not an Android developer? Good. Did any of you try to write a library? See? So, why would you write a library in the first place? This is a very general question. It's not only about Java, it's not only about Android, it's purely why would you write a library? Well, the first reason is modularity. You want to be able to split your code into smaller units, and that brings many advantages. Of course, those smaller units are easier to think about, and they're easier to test. So in general, they tend to have a higher quality in the end. A consequence of this is reusability. Once you have these smaller units, you can actually use them in several places in your app, or even across several of your apps. And the last reason is shareability, which is, again, a consequence of reusability. So if it's useful for you, it can be useful for somebody else. So just share it, and actually people will give you feedback, the quality will improve, and you will get your name out there. So why would you write an Android library? Why not just a Java library? Well, there are several reasons. But if you do anything related to UI, you will have to write an Android library. I mean, you will have to put in resources and assets and all these kind of things, and there's no way to pack those nicely into a jar. So yeah, that's the way to go. If you depend on anything in the Android framework, in particular, I mean, Looper and Handler and so on, yeah, then yeah, that makes you an Android library. Sensors, if you use sensors in any way, then yes, there's no way to package your library as a jar. And native code. This is not immediate, but jar actually doesn't have a standard way to package native files in it. And also, I mean, you don't want to put Windows binary inside your Android. It's not your Android phone. So, and there are a lot more reasons, but I mean, if you depend on anything that's very Android related, of course you have to do an Android library. If you have the luck to not depend on any of these, then yes, make your library just a jar and make it available not only for Android developers, but also for Java developers. So how do you start? So that's easy, right? Android Studio should do it for you. So you can add an application module, you can create a new application project, you can create a library module, but oh no, of course you cannot create a new library project. So a quick workaround to this, of course, is to just create a new application project and add a new library module, remove the application module, and you're done. That's a quick hack. Another way to do this is through command line. Always useful, of course. So the Android command comes with many commands, subcommands, and options that allow you to do all kinds of things. So this command will actually help you to create a new library project, and you specify you want to use Gradle as opposed to Ant, and which version of the Android plugin you want to use, and with target, and so on. So actually, I wouldn't put the letter in the package name, but yeah, you get the gist. And while we are at it, you can actually, it's going to be an interesting session about command line from Kenneth. It's going to be pretty interesting. There's always something new to learn from him. He knows a lot. So now you're developing a library. You're officially an API designer. Actually, well, you're an API designer even before. If you start writing interfaces in your code, you're already an API designer, but even more so now. So that can get complicated because it brings up so many discussions, and you run the risk of actually stalling just because of these discussions about what's the right thing to do. So you have to define what a good API is, and there's no silver bullet, there's no single answer that solves this, but there are some guidelines, and I take no credit for what I'm about to say, and this is all from somebody else, and you will see soon who, of course, you might already know. So an API needs to be easy to learn, which is, I mean, it's pretty natural. It has to be easy to use, even without documentation. That means that your method names need to make sense, your class names, your argument names, they all have to make sense. They have to be consistent, and they don't have to deceive your user in any way. This is hard. It has to be hard to misuse. Once you publish your library, you have no idea how it's going to be used. So this is hard to answer beforehand, but I mean, you can see sometimes some patterns when you're coding and see, okay, people might use this. Okay, I'll just document it that, yeah, you have to use it this way, but some people just don't read documentation, so try to enforce it if you can. The code that uses your library has to be easy to read and to maintain, because, I mean, you're writing a library because you want to solve a problem, so don't create new ones. You have to know what your requirements are, and your library has to be powerful enough to fulfill them. So choose your requirements wisely. This is not as important, but it's a nice to have. It has to be easy to extend. So if people want to add some functionality, they don't necessarily need to fiddle with your library. They can just extend it with something else. And yes, you have to choose your audience. It's the same way as when you have to choose your requirements, but you also have to choose your audience, because you cannot make everybody happy. You are trying to solve a problem, and you're developing a library, which is your opinion on how to solve the problem. So don't try to please everybody, don't throw the kitchen sink at them, just do what you think is right and be consistent about it. And yes, all of these rules are not by me. I'm standing on the shoulder of giants, and Joshua Block, of course, is the man. So read this book, buy it and have it by your side all the time. It will save your life, and most importantly, it will help you win some discussions with your colleagues. And he also gave this presentation. You can find the slides online, and probably also a video on YouTube, how to design a good API and why it matters. So very relevant. So an example. We have to choose how to save some information. And which way would you go, A or B? Do you just add a save method, or do you actually make explicit transactions? So let's take a look. Well, A is more compact, of course. It's just a save method. It's nice and short. B is more expressive. There's no magic going on behind the scenes. You know there's a transaction going on. Probably in that save method, there will have to be a transaction. So you have to choose if you want to expose that kind of abstraction to your user or not. A feels familiar. I mean, it's just a save method. What can possibly go wrong? You know exactly what it does. B allows to have, you can save more than one object in the same transaction. If you have the save method, then you have to call the save method for every single object. And transactions are not cheap. Or both opening and committing a transaction, it can be a quite expensive operation. So if you can batch some operations, that's actually a good thing. And B allows you to work with zero copy. But if you have a save method in the end, it means that that information has to be first stored in memory somewhere and then copied. So if you want to provide some zero copy functionality, then of course that has to be considered as well. So yeah. Next challenge, testing, everybody's favorite topic. Of course, testing is super important for applications, but it's even more important for libraries because you have no idea of how people are going to use it. So you have to try with all kinds of parameters, of all kinds of combinations, and so on. So writing a unit test for a library is exactly the same as writing a test for an application, so I will not be teaching you that. But as a suggestion, try to go for JUnit 4 over JUnit 3 now that you can. And that's because JUnit 4 allows for using parametric tests. It's actually possible with JUnit 3, but it's pretty cumbersome, and you have to write a lot of boilerplate code. So prefer JUnit 4 if you can use it. Automate as much as you can. So testing is tedious, and you forget to do it before committing, and people get mad about it, and then a bug slips in, and you find out that running the unit tests. So try to automate as much as possible. And I'm a CI freak, and in particular, I'm a Jenkins freak. So my suggestion is to let Jenkins become your best friend. Let it automate everything it can for you. You can use it as lightly or heavily as you like. I mean, you can treat it as a cron on steroids, or you can use it for all kinds of crazy frameworks or workflows. So just use it. I have nothing against JVCI or CircleCI. They're very good tools, but when you try to get more advanced and you try to have more personalized workflows, then I think Jenkins is the best option. Jenkins offers more than 1,000 plugins right now, so it can be quite intimidating when you first start. So which one should I install? Which one should I not install? So here are my top 5. Job config history, that's very important. That means that you can give everybody the permission to actually fiddle with the server, Jenkins server, and that can be scary if you cannot track everything and roll back. So this plugin actually allows you to do that. So you can see all the states of the configuration, and if somebody messes up with something, you can point fingers and roll back. Git, a no-brainer. I don't want to think that anybody here doesn't use Git. So, of course, you have to install the Git plugin. The Android emulator plugin, it's actually a pretty deceiving name because it does a lot more than actually managing the emulator. It actually allows you to do all kinds of things, running monkey tests and present them nicely in the end. And so it's a very nice plugin done by Christopher Orr. He also has some presentations on YouTube and so on, so you can take a look. It's a very good plugin. The matrix job plugin is very important, of course, and what it does, it allows you to define some axes and some parameters. Familiar to app developers, probably screen resolution is a big factor, so you can have an axis where you test the different screen resolutions, and the other axis with I don't know what API level it's running on, and so on. So it takes some time, but you have a great coverage of all the possibilities. And JUnit, of course, so you're able to track what's going on, and you see the history, and you can see the graph for the unit tests, always going up, of course. And the last two are actually come preloaded with Jenkins, but don't forget to use them in your jobs. So, and the third solution to the testing problem is actually to write some sample apps. And that might be a bit weird to think about, but there are some reasons. And well, first of all, they actually act as additional integration tests. So you have your unit test that tests the single methods and so on, but actually the application tests the whole library as a whole. Then you have an opportunity to showcase how to use your library. So your users will actually be able to go and use these sample apps as a reference. What are the best practices, how to use this library? And of course, it helps you to validate your principles. You started your library because of a reason, and you wanted to solve a problem in a specific way. And if you write a sample app and then you realize that, okay, maybe I didn't do a good job. So it's always a good idea to validate what your propositions were. So next, what kind of artifact to generate? So given that you don't use some UI assets and so on, so maybe you just depend on the Android framework. So you could, in theory, just produce a jar. So yeah, it's a possibility. And even if you have native code, there are ways to actually include them in a jar. And yeah, the Gradle plugin seems to do a good job. And so how do you decide what to do? And it all boils down to a question. Do you want to support Eclipse? Who would like to support Eclipse here if they wrote a library? Who uses Eclipse? The same guys. Okay, move on, guys. The solution is just use AAR. It's what Google offers now, and it's very flexible. It allows you to do ABI splits very easily, which means that, for example, if you use native code in your library, your users will be able to create smaller APKs for the different CPU architectures. So it has a bunch of good advantages. So I will just stick to AAR. Next, so you wrote your library. It's amazing. Everybody's happy. Now it's time to make it public. Where to publish it? Did any of you try to publish something to Maven Central? Okay, then you have to trust me. It's super painful. It's a really, really tedious process. And the solution is to use Bintray. Bintray is a great service. It's free for open source libraries. And it comes with a nice UI, so you can track how the downloads go and so on. And it's easy to use. And Bintray is actually the repository that's behind JCenter, which is a superset of Maven Central. So if anything is in Maven Central, it's also in JCenter. And by default, when you start a new application project now on Android Studio, it will actually use JCenter instead of Android Central. So yeah. But when you publish a jar, an AAR in a repo, you have to create a couple of extra packages. The first one is a jar for sources. And this is the way to do it in Gradle. It's very simple. You just create a new task of type jar, and it's a one-liner. You just point it to the source directory. So very easy. Javadoc is a little bit more complicated, but not so much. So here we go through all the variants, and normally it would be just release and debug, but you can have more if you like. And for each of those, you create a task of type Javadoc, and you specify the parameters. The only bit weird thing is actually that ext Android jar part, where you actually get the class path of the Android project, so you can actually reference whatever you use from the Android library, and they will not appear as broken links. So you add that in the end in the class path. And of course, you want to exclude your build config and r.java, because nobody's interested in those anyway. Bintray also provides a Gradle plugin, which is pretty nice, but it's a bit cumbersome to use, especially if you're not super familiar with Gradle. So my suggestion is actually to start doing releases manually using the website, and that will become annoying and tedious, and then you will be motivated enough to learn Gradle and to use this plugin. So that's my suggestion, at least. So getting more advanced, there are some challenges ahead. So in the Android world, reflection is slow, actually painfully slow. Java seems actually to have solved the problem, but in Android it's still quite a big problem. Why would you need reflection in the first place? Well, sometimes you need to make the life easier for your user, and that means that you have to generate some code for them and allow them to have to write less boilerplate code. And the way to do this is through annotation processing. Annotation processing comes with some pros and cons. Well, the first pros is that it allows you to write new Java files. So given some information, given some annotations, you can follow which classes this annotation is being applied on, or which field, or which method, and then you can make decisions based on that and generate new code. And it happens at compilation time, so all the penalty is paid when you compile and not at runtime when it really matters for the end user. It has some problems. The first one is that it doesn't allow you to modify existing code. So you can only add new Java files. You cannot modify existing ones. And the API is not exactly friendly. The documentation is a bit fiddly. So it's not super easy to use, but there are quite a few libraries using it right now, so you can actually get inspiration from there. Some very cool libraries use it. Dagger, of course, Butterknife from Jake, auto-value, auto-parcel. This is also very useful, if, especially parseable is quite tedious to implement, and we're using it as well, and a lot more, really a lot more. The problem here is actually that the Android framework does not provide you with the package you actually need to do all this. JavaX annotation.processing is not included. So what do? Well, you have to create 2 Java sub-projects, or yeah, sub-modules if you want. The first one is actually for the annotations, and the second one is actually for the annotation processor. And you want them separate because actually the annotations, you will need them both from the annotation processor and from your library itself. So it's nice to have this separation of concerns and have everything nice and tight. So now we actually have to change the way we generate our Java doc, because now we also want to add the documentation from the annotations, and now they reside in another module. How do you do that? Well, luckily in Gradle it's just a one-liner. So you add the folder of your annotation, and be careful. It's not a typo, the missing equal sign. It's actually important. So source equal means that it's an assignment. So it actually gives the value, and source without the equal is actually a method call, and it just adds to the existing ones. So be careful about that. As an example, we actually, when we created the first proof of concept of our product, we didn't use annotation processing. We were just testing that things will work out. And we used something called DexMaker, which is a library that allows you to generate Dex code on the device. And that was incredibly slow, like painfully slow. To generate a class, it could take maybe 1 second. And if you had to generate a bunch of libraries, that's not a penalty you want to pay. Yeah, we decided, of course, to use annotation processing to generate those classes instead, and the code was like 10 times faster immediately, and after some further optimizations, it got a lot faster as well. So, that being said, sometimes annotation processing is not enough. Why? Well, I stated one of the limitations before, the fact that you cannot modify existing code. You can only create new code. And sometimes you really need to generate new, to change some existing code. And the solution to that is bytecode weaving or bytecode manipulation. And same treatment. Yes, it allows you to modify existing code. So that's nice. And actually, the API is much easier compared to annotation processing. It's actually more similar to Java Reflection, so it's something you're familiar with. But you really need to know what you're doing, because now you're going behind the back of the compiler. You are changing bytecode. So if you mess up with something, there's no safety net. You're screwing up. And you have to be careful about what you're doing because it might look weird in the debugger. So if you modify some code and add some instructions and then somebody steps through that code, then what happens when you actually go through the code and then you add some lines and the debugger keeps going on. So it's a bit weird, so be aware of that. So my suggestion is to actually try to do as much as possible with annotation processing, and in the end, just change those 2 or 3 places with the bytecode manipulation in a way that doesn't look weird in the debugger. So don't add lines and so on. There are several tools that allow you to do this. ASM is one of them. It's very popular and very fast. AspetJ is another. I think JENKINS uses for Hugo. And JavaSys is another one. And there's a lot of work revolving around JavaSys and Android, and mainly due to this guy. He wrote a lot of code to help doing this. And actually, this repo doesn't contain any code. It's just a list of projects that actually use dependency injection as a showcase. So big props to him. As an example, sometimes annotation processing is used to generate proxy classes. So classes that fake to be the class that the user defined, but actually override some behavior. So if you do that, it means that you're overriding methods. So it means that you have some limitations. So you cannot use public fields. You cannot allow public fields because you cannot intercept calls to fields normally. So you cannot proxy those. Also, since you are overriding methods, but there's no way for you to know exactly what these methods do, then you need to actually enforce some rules about the naming of these methods, and especially getters and setters. And sometimes people get creative. They like to give some special names to getters and setters, so this sometimes bites you back. And no custom methods are allowed, again, because you don't know what it's doing. So you might override it, but then you have nothing, you don't know what to do with it. And of course, a consequence of this is that you cannot implement interfaces because you cannot add custom methods. So, but you still want to allow to do stuff like this. So you have some public fields here, you have a toString, but it could be whatever name there, and you want to be able to do things like this. But if you have a proxy class, this is not possible. So how? Well, here, of course, is a combination of annotation processing and bytecode weaving. And the first step is to actually add some custom accessors in your proxy class. So this is the proxy class. It's a person proxy that extends person. And you create these strange names. I mean, you choose your own convention then. You're not tied to any convention to enforce to the user. They can choose whatever they like. But you generate this, and then actually the first step in bytecode weaving is actually to add the same getters and setters in the actual class. So you're adding methods, and all they do is actually to do whatever a normal getter and setter would do. And then the second step will be actually to do this, to substitute any access of the field you're interested in to the actual method you generated. That means that now, if a user calls toString, it will actually call name.$getter, which will actually be intercepted by the proxy, and that will do all the data access that you want to do. So you're home. And then there's native code. Sometimes you need it, and when you do, well, sometimes you're in trouble. The bad news is that the actual Android plugin right now doesn't allow you to use NDK. It actually does allow you, but it comes up with a big warning saying, hey, this is not supported, and we're working on it, and so not really working real good. But it is true. They are working on it. There's an experimental plugin for it, and it seems to be working pretty good. So it changes something. So this is how you use it. You actually add this dependency, so the difference is the experimental part there and the version. That's the latest version I know of, as of 2 days ago. And also the model part in the package name. And the DSL is also slightly different. Now everything is enclosed into a model closure, and you have to use properties and not methods, so you have to remember the equal sign, and you have to do some other things. But there are a bunch of rules, but it's not too difficult to convert the Gradle file to use the new syntax. But yeah, this is the address to find out all the informations, because, I mean, there's still a version 0.2.0, so probably they will change something. I don't want this talk to be updated just tomorrow. So take a look there, there's more information, and it seems to be working pretty good. But there's an annoying limitation. There's no support for creating or depending static libraries, which is what we need, actually. But is there? Actually, I tried this morning, and it seems to work. So in the website, they still state that it's not supported, but it actually seems to be. So that's ending the talk in a good mood. And I want to thank you for being here. Thank you so much. And I would like to hear some questions. Right.